Yeah. All right. So what we're going to look at is how you can tell what the units are whenever you're dealing with problems pertaining to rate. Okay. So when we have a function, you guys, there is an input and there's an output. The input is the one inside the parentheses there, and the output is, of course, the one that comes out. Oops. Now, when you're doing word problems, they have units associated with them, right? So X is going to have some units, and Y is going to have some units. Okay. Now, so for example, let's say that, you know, when you're driving a car, every minute you go so many miles. So in that case, the time would be your input, the miles would be your output. Okay. So now when we're doing calculus, we do derivatives, right? So let's go ahead and we'll write this. Anytime you have just an F, all that's going to be is an output unit. You know, so if they say find the value of F, well then your answer, like going back to our example, the answer would be miles, and that's it. Okay. Now, if you have an F prime, that becomes a rate. And so you end up with an output unit still, but it's an output unit per input unit. And then whenever you have F double prime, you have an output unit over an input unit squared. So basically, as you guys can see, every time you take a derivative, you just add an input unit to the denominator, right? Yeah. Make sure you put an arrow on this to symbolize the direction. So
No, Mr. Bailey, it's okay, man. You just,
I was picking on
okay. So
Is your brother dead? Yeah.
all right, guys. So, but this can go backwards as well. So let's say that you were to start off with,
The output over the input.
if we start off with like something that's kind of like a second derivative, I wonder if I can, you know, let me rewrite this. I'm going to change the function here. Let's say that G represents something, right? But G is a function that represents something with the units that look like this. Output unit over,
I have a reason. Think of input units.
input unit squared. So, because your function can actually start with the units of a second derivative, right? So that might be the starting function they give you. It's already an acceleration, in other words. But in that case, you're working backwards, right? And so that's like not taking a derivative, but like taking an integral of it, right? Yeah? No. Just a sec.
That's just the values of G.
Now notice here, by taking an integral, we lose an input unit on the bottom. It used to be squared, now it's just going to be an input unit, okay? So it's a regular rate. And in the same way, you could take an integral twice, Now I've never written it like that, but haven't we taken integral twice before in here?
No.
Yes, we have.
No, we haven't.
No.
Probably have.
Yes.
I would have remembered bacon.
Well, you can, right? You can integrate this to get here, and then you can integrate again to get back, right?
But is that how you would write
That
it?
is actually how you write
That's
it.
crazy.
All right. So a double
If we combine
integral.
two integrals together with that, they do the same thing or no? We haven't taken the. I mean, I've seen that before, but it was because we combined two integrals.
It just means you're integrating twice simultaneously. It's not combining integrals. Yeah.
Which is not two different sets of limits.
Right now, I'm not worried about limits. I'm just worried about antiderivative. So indefinite integral.
So yes.
In that case, you just end up with an output unit only. Okay. So the point here is that as you work your way this way, so each time we integrate,
Add an input unit. No, you take out an input unit.
yep, we remove an input unit from the denominator. Okay. Now there's another way that we could say this. I'm gonna put it in parentheses here. If you're let's go back up here to this one up on the top. Every time we take a derivative, we put an input unit on the bottom, right? Well, that's the same thing as dividing by the input unit. So this sentence here, we put an input unit in the denominator. What that means is divide by an input unit. Over here then, if we're removing an input unit from the denominator, we're multiplying by an input unit. All right, so there you go. So that's units. So that's like the raw stuff, but let's kind of start putting it to practice a little bit and see if we can make some sense of it. Has everybody got this copied enough, or do we need a minute?
Yes, sir. I'll skip it.
I don't want you guys to say these answers out loud. I want you just to write them down, and then what I'll do is I'll call on you guys to see what you think. So for number one, I'm going to give you a function here.
Why'd you put guidance?
All right, let's say that f of x, which is y, is, let's just say rabbits.
Rabbits?
Yep. And let's say that the input x is
Carrots.
It's rabbits.
Carrots. Yeah, carrots.
sure carrots. Okay. Here's what I want you guys to do. I want you to tell me what each of these would mean here. Like not what they mean, but what are the units, okay? So
I got it, sir.
old shot here, so let's see how we do on our first take. So if the output unit f of x equals y is rabbits, so the answer is rabbits for f, right? And the input variable, which is x, is carrots. Then, I mean, what would the units be for f prime? Yeah, whatever that means. Rabbits over carrots, or you could say rabbits per carrot. And so, Zachary, what would the next one be?
Rabbits over carrots squared.
Yeah.
Gosh, Zach, you're so smart. Nicola, you're not supposed to be saying it out loud, bro. What did I even say? I didn't say it.
Or you guys should probably write this down. Yeah, you would say this one is rabbits per carrot per carrot.
Rabbit per carrot.
I call her a rabbit. She be eating my carrot.
Okay, let's do another one.
This is why I expect calculus to be like slow and steady, and then actually knowledgeable.
Let's say that the units are this time.
Speed of car.
Speed
of sound.
Students per study. Per teacher.
Students per teacher. Students per book.
I like that. That makes sense. Students per teacher.
Students per depression.
Now let's say that G is a function, and the units for that function are students per teacher. Okay? The units for G are students per teacher. So I'm going to give you guys two things to give me the units of here. I want you to tell me, what does G prime represent? What would the units be for that? I would like you to tell me, what does the integral of G represent? William, what are the units for G prime?
That's not a unit.
I got you, Bailey. Just go ahead.
No. Let me try. Let me try Sean. What are my units for A? Yes. So since G is already a rate, students per teacher, if I take the derivative, I'm going to add the input. So from up here, what is the input unit?
Students.
No.
Teachers.
It's the teacher. This is the input. This is the output. Okay. Well, I don't really want to say it like that because that's not technically true here, but the output is students per teacher, so I wouldn't write this down. But what I do want you guys to be aware of is that the input we could clearly see is teachers. The second one is teachers. So if I take the derivative of students per teacher, I'm going to add a teacher unit to the denominator. Okay, and so that would be students per teacher squared. All right, let's see. Lucio, what would B be? Okay, so what we learned was that when you integrate, you lose an input unit from the denominator. So what would it be?
Students.
You're not Lucio.
Sorry, Lucio. It's
Yes, sir.
Okay, well, G, what are the units for G, Lucio? So if I lose the input unit from the denominator, what will it be? Just students. So when you take a derivative, you add an input unit to the bottom. When you integrate, you lose an input unit from the denominator. All right?
Get it. I've been doing it wrong.
All right, let's do another one. Let's say that W of X equals Y is a function whose units are
Donuts.
dogs
Per cat.
per minute
Dogs per minute.
per minute.
I run dogs per minute.
Dogs per minute, yeah.
What if we integrated like students by itself?
That's a good question.
Get them.
All right. We'll get to that. We'll get to that. That's a good question. We're going to do that. All right. So here we go. What is the integral of W? What is the double integral of W? And then to answer Luke's question, what would be the triple integral of W?
Oh, I know. That's job one preferred. I did it, guys.
What do you think, Art?
That's dogs per minute.
Shut up.
No. Let me ask Daniela. dogs per minute. Okay, so when we integrate, we lose a unit from the denominator. So I've got 2 minutes here. That's my. I've got 2 inputs down here, so I'm gonna lose one of them, and I'm gonna be left with dogs per minute.
Yes.
All right, next, David. What would the next one be? That's just dogs. You lose the minutes, and you're left with dogs. Next, Aaron.
Cats.
Does not exist.
Oh, good question. Good answer, but no. Luke knows what it is. What is it, Luke?
Dogs times about a minute.
It's dog minutes.
Dog minutes. One dog year is
I don't. How does that make sense?
Well, I haven't given you a word problem, so it doesn't. But you know, one example that pops into my mind here is how the electric company charges you guys money. They charge you kilowatt hours, don't they? 2 minutes they're being multiplied together, kilowatt hours. So this is an example of where I don't know, like what can we do here? Like let's say it's a place that cleans dogs. So this place cleans X number of dogs per minute, let's say, right? Well, the double integral would basically be telling you the number of dogs they got cleaned at the end of the day, right? The double derivative would tell you how the rate of change of their rate of change. So like maybe they're getting 5 dogs done per minute here, but 6 dogs done per minute here because they have more workers. So the original one would be telling you how quickly the rate of change is changing. The last one would basically, what the heck would that tell you? Dog minutes. Multiply the number of dogs times minutes.
So
I have no, I don't think that one has any meaning here, honestly. Yes, I'll give it. Thank you. All right. So, and now what? Now remember what I said. Why does this work? Because what we said earlier, I said it in 2 ways. One is you're removing a unit from the denominator, right?
or you're multiplying.
But it's really multiplying. So you're multiplying by time. So when I go from here to here, I'm multiplying by minutes, and I lose a minute from the denominator. Multiply by minutes, you lose a minute. Multiply by minutes, that's dog minutes. Whatever that means.
This makes 0 sense the way you're explaining it.
Wait, so dog minutes would be the rate of the change.
You're just like, yes, dog minutes, bro.
So there could be a dog.
Why did you have to use those units? You can use like actual stuff that exists.
Sorry, I'm making this up on the fly. Yeah. Huh?
Dog minutes.
Yep, dog minutes squared. But not dogs per minute squared, right? That's different. So it's dogs square minutes. Whatever that means.
Dogs minutes or dogs minutes squared?
I would say dog minute. I don't know. I've never seen that honestly. But
I've never seen dog minutes.
you have today. All right. So here's what I want you guys to do. We're gonna switch gears with this topic a little bit. I don't have as much time for this as I would have liked to. But I think you guys have the idea. So here's what I want you guys to do. Get out your blue books.
Are you gonna check all 6 of them?
I want you guys to open up to page 53 for me.
Make us do all 6.
I might have done that.
We should do the entire one.
Oh, that's why Zach was like, I'm doing this whole thing.
It's not gonna make it. All right. 53.
53.
All right. So I want you guys to take a minute. I want you to look at the graph. I want you to read the directions. Then I want you to read part A. I'll give you about 2 minutes to study that, and then I'm going to ask you a question. We're not going to actually do this FRQ. We're just going to talk units here, okay? So go ahead and read the introduction there in part A. So I asked you guys to take a look at page 53 in your FRQ books. Okay? And then for part A, they ask us to find this. I want you to interpret that for me. Now, the most important thing is just getting the units, okay? But if you could also interpret it as well in the context of the problem. So go ahead and give it a try. I'll give you a minute.
Gallons per minute. Well, gallons per minute are the units. And then minutes. Oh wait, yeah. Gallons per minute and then minutes. But T is not in that equation. So it's just gallons per minute.
No. All right. It's gallons per minute per minute. Now here's why. Look at R. Look at R at the very top. What are the units for R?
Gallons per minute.
R is gallons per
I wasn't giving you the answer. I
minute.
thought you were just asking for the units of the actual equation.
Okay.
That is the unit.
So now the derivative would be gallons per minute per minute. Now the interpretation, like what does this even mean? Luke Jones, what's the interpretation of this then?
Yeah. It would be how fast the fuel consumption, like the rate of change for the fuel consumption is changing.
Good. At
R 45
minutes.
minutes. Very good. So this is how fast the rate of change is changing at 45 minutes.
Yes.
Or you could just say the rate of change of R at t equals 45. So when you do an interpretation, you guys, you have to include the time unit as well,
All right.
if there is one. All right, let's take a look at the next one. Let's do part Let's do part C. Part C. Take a look at part C. On part C, you're seeing something that looks like this. Right? All right. So I want you guys to interpret. Since R is gallons per minute, I'm integrating that so I lose my time factor from the bottom so that the units are going to be gallons. Now, these are my time intervals. So I need an interpretation here. So Moises, what do you think the interpretation of that would be?
Amount of gallons from 0 from T to 0 to 90.
Good. And I didn't read the word problem whenever you guys were, but is it about a car losing?
I got you.
Airplane.
An airplane, is it losing gallons or what?
Yeah. Oh, so
It's losing consumption.
Okay, so basically this is how many gallons it loses for 90 minutes after 90 minutes, right?
That's a lot.
So
This aircraft is inefficient. Fly with Boeing. Bro,
the amount of gasoline lost after 90 minutes. All right. I think I'm going to go ahead and stop there with this, but hopefully that has clarified things a little bit. What I would love to do, if I'd had everybody already take the test, is put one of your guys' test questions up here, and you guys can kind of see it.
What's that?
You should do that anyways.
You should do it anyways.
Just because
just change the equation. Don't you?
I'm not going to,
All you
but
need to do is click
that was your guys' weak spot. You know what? Let's do one more thing really quick, because this is actually a different take on the matter. Would you guys turn for me to page?
One number two.
Turn for me to page 133.
And we did that one. 3-3. What? What was number?
We did that one?
Years.
Oh, that's not
Yeah, we
good.
did.
The first one is cars.
Did we do page 135?
Yep.
Did we do page 137?
Yep.
No.
No, I'm kidding.
No. All right, let's do 130. I want to give you one you haven't done yet. 137. Give me 137. All right. So I'm gonna let you guys read this, but before you guys start, listen up to me real quick.
Yes, sir.
Part A. Part A is asking me to find the total number of cars.
Turning left.
So it's asking for a total number of cars. So what I'm going to ask you is, what do they want you to do? All right. So that's my question. We're not going to actually answer this question, but the question you're going to answer for me is based on what you've read, based on the units. What do they want you to do in part A? So go ahead and read the problem. What do they want you to do? Mario, what do you think? What mathematical process do you think they would want you to do?
Integrate.
The answer is integrate. Now let's see why. First of all, they give us a function, right? L of t. What are the units for that function?
Cars per minute.
That is cars per minute. Hour. Cars per hour.
Our time.
So now, what are they asking for though?
Cars.
Cars. So if we're going from cars per hour to cars, I lost a time unit in the bottom. So that must mean I'm integrating. Now, the problem could be more complicated. I'm not looking at the details. But we do know for certain that we're integrating something here because we're going from cars per hour to cars. So as you guys can see, just knowing the units can also be a nice hint and clue into the process you need to execute to get the answer. Yeah.
Real quick question about the FRQs on the actual test.
Yeah.
Which ones can we use calculating and which ones can't?
The first 2 or 3, it varies, but like the first 2 or 3 are calculated, the last ones are not. And actually starting today, I'm going to start putting which one of those, because they don't put it in the book, which ones were calculator active and which ones were not. Okay. And I haven't put your stuff on the board for today, so
I don't know about it.
but it will be up.